Hi there. In this video, I'll explain the working of the complete sketch that we have just seen in the previous video, which shows the temperature and the humidity data on our dashboard. So this is going to be a single sketch that will give you the idea how the sensor works with the dashboard and how we can integrate more similar devices. Either it can be a motion sensor or ultrasonic sensor, gas sensor, flame sensor, or whatever, any kind of sensor that you want to integrate. So let's move on to the sketch. This is the sketch itself. Let's start from the top. Here we have all the library files that we need for this sketch. First one is ESP8266 Wi-Fi.h. So this library is used to maintain the Wi-Fi connection in our Node MCU. Now second one is the PubSub client. This library is used to maintain the MQTT connection as well as to receive and to send the data from the device to the MQTT broker. Task scheduler is to you can say that you can do multitasking with this library in Arduino, because we are using ESP12 here and there is a problem with ESP12 that it comes with a single core. So you just cannot use a real-time operating system which is available with ESP32, which comes with dual core. So parallel programming we have to do with this task scheduler. Then we have this dht.h library for this DHT sensor, temperature and humidity sensor. So these are all the library files. Now we are defining some important things. The first one is the DHT pin on which we are connecting our DHT sensor. So our DHT pin will be D2. So the Node MCU's D2 pin, we will be using it to connect our DHT's output. Then we have to specify the type. So we are using DHT11 as the DHT sensor type. Here is the refresh time. So I am writing it here as 5000 milliseconds. So after 5 seconds we will be transmitting the data on the server. So here, as you can see, we are publishing the data. Cool. So here we have the device ID. We have device ID as of string data type, and we have our credentials. This is SSID and the password for Wi-Fi router. This is for MQTT server. This is username and password for your instance. And this is the published topic. So this is going to be the same for each and every one of us. So we'll use it as pub topic. And here we have the element ID. If we have further elements, then we can add string, element name, and again their element IDs. These are the two important things now: will message and MQTT status. In the MQTT video, I must have missed about the will message intentionally, because at that time you guys must not understood about what I'm saying, but here I'll explain you about the will message. So a will message is a message that MQTT device publishes at the time of making the connection. So when the when the device is connected to the MQTT broker, it publishes that will message at the time of connection, but it's like it stores it at some place, and it will only publish that message to the broker when the device is disconnected. So here we can see it is called the will message. So let's say my device is connected, it stores the will message inside it at the broker, and when the broker pings the device and it is not active or the device went offline due to some reason, then it will publish the will message automatically. So this will message will let us know that the device is offline because we are storing it as offline. So this is the format for the payload. So what basically I am building here is will message is our payload. So the payload is like dev_status. In the publishing formats, we have learned that to publish the connection status, we need to write dev_status. This is the space plus your device ID. This one is the device ID. So I'm just using string concatenation here to concat each and everything, plus space and offline. So what it will become, the final message will something look like this: dev_status space, then here comes your device ID. So here is the device ID. After the space, it will look like this, plus offline. So this is the complete message that we are sending on this particular topic when the device is offline. So if I disconnect the device now, you can see that the status of the dashboard changes from green to red. So this is about the will message. Now MQTT status is the payload that we are printing when the device is back online or when it is connected. So let's say dev underscore status space device ID space online. This is the complete message that we are sending when the device is online to check if it is online. These are the signal strength. This is the maximum signal strength, this is the minimum signal strength, and we are storing it in, again, we are making a variable of string data type. Now we are using a task scheduler. We are creating a task that repeats itself after 10 seconds. This is the refresh time. I can directly use here as refresh time, then it will repeat it after 5 seconds, or let's just keep it 10 for the time being. It will run forever and it will call this temperature function. What is this function? We have to define this particular function. So I have defined it down here. This is the temperature function. So what it will execute? It will first give a delay of 5 seconds. I can use the similar delay here. Then it will read the humidity. This is the function to read the humidity, and we are storing it in a float value. Then it is reading the temperature with this function dht.read temperature, and we are storing it in a variable called t. Then we are just printing the temperature and humidity on the serial monitor, and as you can see here, we are just printing the humidity and temperature. So this is, we are just printing it. Then we are also printing this line, publishing device status and signal strength. As of now, we are just publishing the device signal strength. So this is how we use the publish function. Client.publish, I'll take you through it after I explain the callback and reconnect function. So for the time being, just remember that we are publishing the signal strength with this function, and here we are publishing here we are creating the actual data, and then we will publish it. So this is we are creating for temperature, and this is the payload that we are creating for humidity. Remember I told you smarden underscore dev underscore sense is for temperature, sensors space your temperature ID. Here we are using your element ID. So element ID for temperature is temp ID. So we are using this one. Control C. Let me show what you will get from here. So the message will become like this: sense space your ID space. So this is the space, and string T. We are converting float into string because the payload must be in string data type. So let's say the temperature is 34 degrees. So it's something like this. So this is the data that we are publishing on this pub topic. This is the data, this one, temp underscore message. .cstr is to convert it into a char array. So this is a function to convert it into a char array, because we just can't publish the string. We just can't use a string directly with this function client.publish. Similarly, we are creating the data for humidity. Let's say smarden underscore, sorry, I have used hyphen here. It's not hyphen, it's underscore dev underscore sens space your sensor ID for the humidity. For humidity it is this one, then paste it, and let's say humidity is 67 units. So that's it. So this is what it makes at the end of this line. So we are storing it in a string and we are publishing it as char array. Now coming back to the line where we were. Okay, here we are just creating objects so that we can access different functions of these classes. ESP client for accessing the Wi-Fi client, and PubSub client is just to access the PubSub client, and DHT to access the functions that are available in the DHT library. Then we are defining a function setup Wi-Fi to maintain a Wi-Fi connection. It's a simple function. We are using the Wi-Fi mode as the station mode, so this is for station mode. Now we are using this function Wi-Fi.begin with the SSID and password that we have just defined here. With this function, this node MC will try to connect to this SSID with this password. Until the time it is not connected, we are using a while loop. While Wi-Fi.status, this function will return status of the Wi-Fi. If it is connected, then it will return WL connected. If it is not connected, then it will return something else. So what we are doing here is we are using this function, and until it doesn't match this one, WL underscore connected, this is not equals to, until this function doesn't return the same value as this one, that means until the Wi-Fi is not connected, we are printing a dot after every 500 milliseconds on the serial monitor. Now if it is connected, the condition is false and this will run out of the loop, and we are just printing the data Wi-Fi connected with the IP address, and we are getting the IP address from this one. We are getting the signal strength in decibels from this one, and we are using a function dBm2% to convert this received signal strength into percentage. So this is the function that we are using. It will return an integer value, as you can see here, return the quality in percentage, and we are just using that thing here, and we are just using a percentage sign. Now for the signal strength, because we have already defined the signal strength as string, we are making the signal strength as sig_strength plus device ID plus space and then the actual signal strength. So at the end it will become something like this: sig_strength space your device ID. In our case the device ID is this one, Control C and paste it here, plus, so let's say the signal strength is 90%, so it will look something like this. So this is the data that we have. Now we can use it with the client.publish function to publish the signal strength. We can publish the signal strength with this payload format. Now we are using the reconnect function. Reconnect function is a part of PubSub client library. It is responsible to maintain the connections to the MQTT. Now it says while the client is not connected. That means until or unless the client is not connected to the MQTT, it will execute this thing here. Sorry, from here. It will execute this complete block of code until the MQTT is not connected. So what it does is, here we are writing attempting the MQTT connection. Here we are generating a random client ID with this random function. Then we are using this particular function client.connect to connect to the MQTT broker with the client ID. Client ID.cstr, we are using it because the client ID is in string and we need to convert it into a char array. Then we are using the username. So here we have username constant char array. This one is the username, this one is the MQTT password. So we are using the username, password. Then we are publishing the will message on the pub topic. We are publishing the will message. This is the will message. So you can see that at the time of connection itself we are publishing the will message, but it will not directly published. It will be stored basically, and it will only be published once the device is not connected to the broker. So this will message is published on this pub topic. We have only one pub topic here and we are using it everywhere, but the payload formats are different. So the pub topic is this one. Whatever we need to publish it in a particular format on this one. So we are publishing the will message here on this topic, and if everything went well, it will print that okay, MQTT is connected. And after connecting, what we are publishing? We are publishing the MQTT status as well as the signal strength. Now if it is not connected, let's come to the else part. It will show failed and reason, and it will print a reason, and we will try again connecting in 5 seconds, and after the delay it will repeat the process. This is db2 percentage. Then we have the setup part. We are starting the serial monitor at 115200 baud rate. We are using this function, we are calling this function so that we can establish a Wi-Fi connection. We are initializing the runner and enabling the task. Then we are adding the task and we are initializing the DHT library. Client.setServer, we have to set the server credentials. So with this function client, which is an object of PubSub client library, so that we can access the function of PubSub client library, we are using this client.setServer, and the server address is MQTT server, which is login.smartin.tech, and the port number is 1884. So this will set the server address. Now in the loop we are just executing our task, and we are checking if the client is somehow disconnected from the MQTT. It will call the reconnect function again, and we are maintaining the loop. So that's it for this program. So this is the complete explanation how you can publish the sensor data on the smartin.tech IoT platform. In the next video we will see how to make a switch device so that we can use the callback functions as well. So I hope you have learned something out of it, and thanks a lot, and stay tuned.